Today's stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, I'm Leandro Fachinacci, and let's write some code together, shall we? What we have on the menu today is, of course, waveform display. We are doing this library that will help you develop better looking and perhaps easier to develop JS effects, so real-time audio processors in REAPER. And we are in the middle, we are 10 levels deep. It's going to be a very nerdy session. We are experimenting with these two squares because we have an issue in the waveform display. The waveform display as it stands, it's looking pretty nice, but it can be perfect. I think it can be perfect, and it's not perfect yet. This is what it looks like right now, and this red bar here is kind of jittery, kind of jumps around, it skips a beat, so to speak. And I think that it can be perfect. How can we make this perfect? Well, this is where this experiment comes in. I will reload the experiment. No, not the waveform. I will reload the experiment. I will explain what is wrong about this, what we can do to fix it. Hopefully we'll be able to even apply it to the waveform display. Maybe not making any promises, but we may even reach like rectified peaks and other features that we want in the waveform display. This may be the day that we finish the thing. I just jinxed it, didn't I? Right, so the square on the top is moving across the screen, and the coordinate of the square is purely based on the timing of the UI thread, on the timing of the GFX block. So this block of code is going to run hopefully 60 times a second, but if it doesn't, because a frame has been dropped or a frame is late or whatever the case may be, then this block is going to like move around slightly weirdly. It may not translate on the stream, because the stream is at the lower frame rate, but the jitter is there, I can see it. The square below is also moving across the screen, but its movement is purely based on the time. So in the script here, we look at the time, and we see how much time has passed since the last frame, and then we move the square across. And note, this is I guess the crucial point, note that the passing of time, so we are asking JS Effects to run our GFX block 60 times a second, but there is no guarantee that it's going to run at exactly 1/60th of a second. There is no timing guarantee between the frames. One of them may be ahead or one may be behind. As long as it is on schedule, as long as we don't go beyond the time allotted, so 1/60th of a second, it's going to render fine. But yeah, timing guarantees are not there. They don't exist. And that's true of any other programming environment. There is no guarantee of timing because there are plenty of things happening on the computer. I am streaming, I am running other software. So there you go. That's the situation right now. And I think I had an idea last time, since Monday, that fixes the square on the top, and it's going to be great. So let's look at the code that is doing the drawing of the square on the top. This is the code. What it does is it simulates what the waveform display does. The waveform display is using a circular buffer to allow the sample block to communicate with the GFX block, and the sample block is writing into the circular buffer, the GFX block is reading from the circular buffer, and we are not really writing and reading into circular buffers here. We are just simulating that by having a counter that is our write index of the circular counter, the circular buffer. And then there is a read index on the GFX block. So sample block is receiving samples and writing into the circular buffer. The GFX block is taking stuff out of the circular buffer, so it has its own read index that is lagging behind but catching up to the write index. This is the line that does that. We are incrementing the read index up until we reach the write index. It's trying to catch up to the write index and then it stops. So the problem is that there is no timing guarantees in terms of how many times the GFX will be called, and there is no timing guarantee in terms of if the GFX block will be called periodically with the same period. Some calls may be sooner or some may be later. And this problem compounds with the fact that the sample block is running on its own schedule, the sample block and the GFX block. So this is the audio thread, this is the user interface thread. They're running at the same time. These two blocks of code are running and they're racing against each other. So things get complicated because I may be writing and reading from the same data structure at the same time. And the idea that I have is, instead of just trying to make the read index catch up to the write index, I will also impose a limit on how many samples I can read, and this limit is going to be based on the time. So I will need to have this notion of time. So I need to grab a few lines from here. I need to grab these two lines. As well as this line. Well, this line needs to be below everything. So I'll just separate this to make sure that I will remember that this line is necessary. This line has nothing to do now with this drawing because we are effectively extracting the notion of counting time, because this block will now start using the notion of counting time as well. So how does it work? Well, let's review what this code does, and then we will see what we can do about this. Because this is the square that is moving smoothly. So we sort of want to, given the title of the stream, we want to draw our waveforms and eat them too. So we want them to be, we want to use this notion of just trying to catch up to an index, but we also want to include the notion of passing of time. We want to have both notions implemented, and we want to check both notions. As long as we do that correctly, I think that the thing will be scrolling smoothly across the screen. It will not desync. It will be great. It will be brilliant. Hopefully. We'll see. All right, so what's going on these lines? We are checking the time. This is our current time. And if the previous time is 0, that is just, it means that we have, that this is the first run of the GFX block. The time previous is going to be 0. Maybe I could even have something like this to make things clearer. I'll just put a value here that in the library, this will be a constant called undefined. Well, I guess I will define this constant here real quick. Undefined is equal to that. And then that. So I will say that to begin with, the time previous is undefined, and then here I will check if the time previous is undefined, then the time previous is equal to the time current. I don't want any movement to occur. No time has elapsed. Great. And then down here, we just update the previous time to be now the current time, so that next time we go around the loop, time previous will have the right value in there. Great. Now let's see. What's next is we have to know how many samples we are supposed to read given that this time has passed. So let's compute the variable whose name is how many samples should we read at most given the time that has elapsed. Now this may not be the best variable name, but because I made it so long and capitalized, I will remember that I need to rename this. So let's reason about, first of all, how much time has elapsed. That's easy. That's the current minus the previous, right? So this is how much time has passed. Now we need to know how much we want to move. So I think that the formula is actually going to be similar to that, but it's not going to be quite exactly that. Yeah, we'll see. I will not try to copy and paste and adapt. I think I will reason about this from first principles. So this is how much time has elapsed. Suppose that 1 second has elapsed, because that's going to make things easier to reason about. How much do I want to read? How many samples do I want to read? Well, it depends on how many samples make this distance. And of course, we are now talking about things in terms of samples and distance. So of course, we are reasoning in terms of the waveform display. So how many samples translate to going across the screen? And this is not something that we currently have. Well, I guess what we are doing is I guess this is just based on the blah, blah, blah. Right now, we are just advancing every sample that we read. For every sample that we read, so every time that this block goes and executes, we are moving this much. And none of these values seem to be related to the size. Yeah, of course, the updating of the read index has to do with the size. But computing this has nothing to do with the size. Yeah. So if 1 second has passed, how much do I want to move to the right, and how many samples that translates to? Well, it will have to do with the width. And I guess it will have to do with the duration and the sampling rate. But I don't know, I just threw the values in there. I'm not sure that they work. But suppose that we have reasoned about this correctly. It's just for whatever reason, anytime I have to do this kind of reasoning, I struggle so hard to reason about like this conversions between samples into pixels, and don't ask me why, but my brain does not process this kind of reasoning. But still, suppose that we have computed this correctly. Suppose that we know that 1 second has passed, and therefore we should read 1,000 samples. Then this is 1,000. This number is 1,000. So what we need to do is we need to have a counter of how many samples we have already read. So I'll just create this circular buffer, read samples count that starts at 0 and that increments anytime we go around the loop. So anytime we read a sample, we increment this counter, and we check that this counter is less than this number. Yeah, I think that this makes sense. So it means that we are going to keep reading samples until we reach the right index. Because if we have reached the right index, there is no point moving further because that is old data. We don't want to read that again. We have already read that. So it means that for whatever reason, by magic, the GFX block is ahead of the audio thread. This should never occur. Now that we have this other notion, this other condition should never occur. But it might, because things get complicated, right? Things are complicated. The universe is complicated. So the second condition is the one that we have had before, and it just means stop at the right index. Keep advancing, but stop at the right index. And this is just us counting how many samples we have already read, and I will prevent the writing of the screen if we reach this, which means that there may be samples that we could read, but we will not. We'll pace ourselves on the UI thread. We'll pace ourselves. There may be some samples in the circular buffer written by the sample block that are ready to read. This, in fact, it would be nice if we could consume them already, because it means we would liberate that space for the circular buffer. And if the circular buffer is exhausted, then bad things happen. The screen is going to glitch. So it is good that it would have been good for us to read these samples, but we are not going to. We are going to say, okay, on the next time that I am called, on the next loop of the GFX block, I will read those samples. I'll just pace myself. I will not try to digest all the information that is available to me right away, right then and there. So this should work conceptually, but we still have to figure out what to call this, and we have to figure out the formula for this. I guess because we have this variable, I will have something based on that. So read samples maximum. And here I will call this read samples count. Or maybe not, just read samples. Yeah, I think I don't need to have the count in the name. It can be just like this. Okay, now this name is good. Now let's figure out this formula. Get tired just to think of this. Then I'll have to figure this out. Okay, so how much time has passed? And let's enumerate what we have on the table. We have how much time has passed. We have the width of the waveform display component, but really it translates here to the width of the waveform display component. This is how much this is going to travel from left to right. Then we have the how long it should take for the waveform to travel from left to right. And this is the waveform in this case is just the square, how long it takes for the square to go from left to right. We also have the sample rate. And I think that should be enough. Oh, maybe we also need the refresh rate of the screen. I'll throw this in there, though I don't think it's really necessary, but we'll just reason about this. So let's think about the units of measurement of all these things. And also let's think about the unit of measurement of this, which is what we want. So what we want is measured in samples. That's the unit of measurement. We want to know how many samples we are supposed to read at most so that it corresponds to the amount of time that has passed. Then how much time has passed, that's given in seconds. Then the width of the waveform display component is given in pixels. Then how long it should take for the waveform to travel from left to right is given in seconds. The sample rate is given in, it's like 40,000 samples per second. The refresh rate of the screen is how many frames per second. So from this information, we should be able to get to that, right? Well, we have samples here on the sample rate. So let's put the sample rate over here in the formula. But the sample rate is samples divided by seconds. So I want to multiply by something that is in terms of seconds. I think I may want to just multiply by how much time has passed. Because that is given in seconds, so it cancels these seconds, and I just get something in terms of samples. And all of this information, the width of the waveform and how long it should take, this should also be factored in. But I don't know, let's just try to see if this is gonna give us anything usable. So this is the sample rate, and this is how much time has passed. And let's see what we get. Wow, look at that. It worked. And they are not desyncing so far. Well, they started to desync. Let's see if we can make them desync. Last time we learned that if I move my screen around, that takes resources from my computer, and then the squares were getting out of sync. That happened on Monday. And if I zoomed in, the same issue happened. It was taking resources from my computer, so it desynced the squares. But these squares are no longer desyncing. They are ever so slightly out of sync at some points, but then they start to sync again, I think. And I have to say, I don't think... Wow, it dropped 500 frames now. But even when the frames are being dropped, it's still in sync, because it's taking time in account. Amazing, huh? Yeah, it seems like this works. And now I'm looking at it, trying to see if I see one being more jittery than the other, and I don't. I think it just works. This is brilliant. This is awesome. What happens when I go to another effect? What I'm doing now is just putting another effect here so that this will not be calling the GFX block, and then it should get out of sync, but it should not be drifting apart or coming closer together. This difference should be the same. Oh, and Bo is here and Tail is here. Hello everyone, how are you all doing? Thanks for joining me today. I think that this idea that I just implemented is gonna fly. What do you all think? There is only the problem of syncing, the problem of detecting whether the GFX block is not running, and in that case, we want to forget about everything, just snap the read index back into the write index and stop or clear the screen, actually. So we just want to do this, to detect whether the GFX block is running. So we could tackle that, or we could try to implement this idea into the main waveform display. And this idea has been used. That was the idea that I just explained. Don't just consume all the samples that are available. In the GFX block, don't just catch up to the write index from the samples block. Instead, let the read index stop early if necessary. Don't always catch up to the write index. That was the idea. I wrote this down so I would remember it for the stream today. So there are two issues that we could handle now. We could handle the issue of transferring this concept into the waveform display, and we could handle the issue of detecting whether the GFX block is even running at all. I think I'm going to do the second. I think I'm going to do the idea of I need to detect that the GFX block is not running and then snap it back. So I don't think there is an API for this. There are ways for you to ask JS effects to keep running your GFX block even if the effects is not running. So let's see if this makes any difference. So coming back here, as you can see, they're out of sync, and when I come out, it stopped running the GFX block. I come back, they are now in different positions. So let's investigate the options that we have here. They're relatively recent, which means that it will not work for people who have older versions of REAPER. REAPER is now in version 53 and this is 44. So it's relatively recent, but I don't really care about backwards compatibility all that much. I am thinking of the future of JS effects here. So this will call the GFX block even if the UI is closed. Let's see if that would have fixed the problem. But I don't really want to use this for reals, but I just want to see what it does. And use spaces to separate multiple options means that I probably want to do something like this. They are in sync. Now the GFX block is supposed to be running, and they are in sync. So the GFX block was running behind the scenes. But there is no good reason for me to force people into use this option, right? Yeah, it's fine that it will be syncing things, and it's also nice that if you have some audio running through this instead of like my voice, well, I guess now it's my voice. So if I had a waveform display running through, I could go to other plugins and I could come back and I would see the waveform of what just happened. But that takes a lot of resources to like draw and stuff, and I don't really need to consume all those resources if I'm not going to show stuff. I think that for the most part, I don't want this behavior. But let's see what other plugins do real quick, just for fun, just to see what the state of the art is. So real image, I think we investigated this before. If I go to another plugin and then come back, what it's going to do is just pretend that this time has not passed, and it's going to just catch up from where it was before, which is more or less what I am planning on doing, detecting that I am not running and then catch up. Then let's see what the M compressor does. So right now it is, I'll move to a different plugin when it's in the middle of drawing, and then I will speak for some more, and then when I come back, it seems like it did the same, but it's kind of hard to tell. So this time I stopped speaking, and now if we come back and there are waveforms to the left of the bar, it means that it was updating on the background. If it's silent, it means that it was not. It was not updating on the background. So that is doing the same as real image. Let's look at the Pro de-esser. And this one is drawing waveforms, and then I will be silent for a moment, and I was speaking. So if we see waveforms on the screen, it means that it's doing the same as the other ones. I'll stop speaking and I'll move there. If it is completely silent, it means that it is updating on the background. Oh, it just resets. So it detects that the plugin was closed and resets. So it seems like everyone agrees with my intuition. You don't want to do this. It's nice that this option is available, but I don't want to do it. What I want to do instead is to just detect that the thing is closed, that the GFX block is not running. And how do I do that? Well, I don't think there is a way for me to query that. I don't think there is a way for me to detect that the GFX block wasn't running because it was closed. I don't think there is any primitive thing that I can use, like to just ask REAPER. Yeah, I couldn't find anything. Yeah, and Tail is suggesting exactly what I had in mind. So there is no primitive thing that I can use. There is no like GFX stopped running or GFX just restarted. No such thing. But what I can do is just check this time. Because if the time that has elapsed, well, I guess at this point I might as well have the time elapsed variable, which is this. And then I can check if the time that has elapsed is bigger than a threshold. So let's say half a second. If I have not refreshed the screen in half a second, it means that the UI thread was closed, that you closed the screen. I think that half a second should be good. So what happens in that case? Well, I will need to reset a bunch of things. I will need probably to erase the screen, but I will not do that here. I will probably do it on the waveform display. Because the real image way of just keeping what the old thing was there, I don't like it. I think I prefer the Pro de-esser way of just erasing the screen. So I will instead just snap the read index back into the write index. This should have the effect of resyncing stuff. Let's try. Okay, they are in sync. And now more than half a second has passed. And they are not exactly in sync. They're not in sync at all. Why would that be? What can I do? Okay, I think I have a way of detecting if this is making sense. I can have reopened is equal or plus equals 1. And this is a trick that I often use to check whether a line of code has run or not. Because by default, reopened is a variable that starts with 0, as you can see here. So now I should be able to go to another screen, and the plugin is still working. But you can see that everything seems to have stopped here. The variables seem to have stopped, because, most of them anyway, because the GFX block is not running. But the audio thread is still running, so it's still pushing into the circular buffer. And that's why this variable is changing. Now when I switch back, I expect the reopened variable to be 1. And it is. Then I switch back, and then everything stops. And I switch back, and I expect reopened to be 2. So it seems like that detection was working. Oh, I should also reset. Yeah, I forgot to reset some things. I should reset the X refresh rate as well as the X passing of time. I will snap them back to the left. And with that, they should always start on the left when I reopen, and they should be in sync every time. They are in sync. They start on the left, and they are in sync. Not perfectly, but good enough. Yeah, it's not going to the left. Why would that be? Well, I guess there is also the problem of time elapsed being used for computing stuff. And here I didn't even replace with time elapsed. But one thing that I can do is, so time elapsed was probably changing the X passing of time here. So I'll just say if the time elapsed is greater than 0, I'm resetting everything. So now the time that has elapsed is actually 0. In sync. In sync. You just have to reset everything correctly, and then it works. Beautiful. So now we did 2 things so far. We have fixed the race condition between the passing of time and the UI thread by introducing this notion of, I guess, we are pacing. We are pacing the UI thread to not read more than it needs to for the amount of time that has elapsed. And because it's not running ahead, it will have enough samples for next time. And this is the square on the top. It's as smooth as the one in the bottom. We also have fixed the issue of them getting out of sync because the UI thread stopped running. In fact, there is something else that I want to do that is related to this UI thread not running situation. When the UI thread is not running, there is no point in wasting resources from the audio thread to keep writing into the circular buffer. Why would it have to keep writing to the circular buffer for no one to read? So we might as well have a variable called This is actually tricky business. I was thinking of just having a variable called like is running in the GFX block and read this variable from here, but it's not that simple because the GFX block will stop running, so it won't have a chance of saying, oh yeah, I stopped running, so I will change that variable over there for the sample block to see. So instead, I would have to check the time at the sample block. But if I check the time in the sample block, checking the time may be slower than writing into the circular buffer. I don't think it is, but it may be. I'll just pretend that I have measured and benchmarked this, and I will go ahead with my assumption that it is fair for me to check the time here. Or maybe maybe I don't have to check the time. Let's see, I'm thinking on my feet here, but let's first start with the simpler thing, which is to just check the time here. So this whole thing, oh, this shouldn't be here. This is a constant, it should be there. This is us writing into the circular buffer. So what I want is to put all of this in a conditional. I only want to run this if the GFX block is running. How can I tell if the GFX block is running? Well, the GFX block is running if time precise minus, I guess, time previous or time current. It does not really matter. I'll just use current. If the difference between the two is less than 0.5. So I am checking the time on the sample block to determine if the GFX block is running. Now the effect of this should be, for me, when I move away from the effect, this should stop on its tracks as well. So everything is running, including this, and this is the one we are interested in. And it stopped. So there you go. That's the simplest thing that can work. Just checking the time on the sample block. But it may be expensive. Tail is giving a good idea. Wouldn't it be more efficient to check if GFX is running from block? Yeah, so the sample block is running 48,000 times a second, while the block is only running on every 256 samples. So just by checking this here, I am making things potentially 256 times more efficient. That's a good point, and it's a good use of the block. But conceptually, what I'm doing is still the same. Conceptually, what I'm doing is I am checking the time on the audio thread. This is part of the audio processing. And is it a big deal? I don't know. Let's see, I'll drop the experiment here, and is it consuming too much CPU? No, it's at 0% CPU. So it's not the end of the world. It doesn't seem to have any effect on the drawing as well. So there you have it. That may be the ideal way of doing this. Is there any other way of doing this? Of checking that the GFX block isn't running without having to check for it again and again? I don't think so. Because conceptually, this block of code is going to die. It's not going to run. So if it's not running, how can it alert that it's about to die? There is no way of doing that. There is no GFX is about to stop block of code for me to run. So the only way is for me to query, is it still running? Is it still running? Is it still running? Is it still running? Yeah. Oh, Bo, no. That's too bad. Post-COVID is acting up again. That's too bad. Sorry to hear that. Yeah, you could keep a counter in GFX and then check that in sample. Interesting. How would that work? I will commit what I have so far and let's try to explore this idea. I have a counter. I will call this counter tail. And anytime that the GFX block runs, tail is incremented. But what do I do with the counter? Both in the block as well as in the sample, in both of these blocks, in the audio thread in general, in the audio thread, the audio thread is running much faster than the GFX block. It's running 48,000 times a second, or 48,000 divided by 256 times a second. So it's running a lot faster, a lot more often, I should say. It's running a lot more often. So it's to be expected, it stands to reason that the tail variable will be the same a bunch of times as we go around this, a bunch of times. Now, what we could do is check that the tail variable is the same it has been for a while. Yeah, we'd probably also need an old tail variable. Yeah, so this is the GFX tail variable. And then I will also have every time I go around the block, I'll have a tail old variable, which is equal to that. And this is not in the GFX block. So I guess this is the block tail and the GFX tail. And then I just check I am not really sure what I would check. And there's something else that I don't really like about this idea of counting, and that is it is subject to glitches when frames are being dropped. Well, I guess the same is true of counting time, right? Because if frames are being dropped, then time current is not being updated, which means that this will also glitch. Well, if block tail is different from GFX tail, well, this is just telling me that the GFX block has just run since the last time that we ran the block. That's all it means, that the GFX block has just run. But we are not interested in necessarily knowing when the GFX block has just run, though that is kind of useful. It may be useful, I don't know. Maybe if you have some sort of buffer where you are putting samples for an FFT and the GFX block is doing the FFT, then it could be nice to know that the buffer is free to be used again, but that's not what we are doing. So this is just telling me the GFX block has just run, because these variables are different. But I guess they would need to be different by a good amount. Yeah, how about this? I think that there is a way of doing this with counting. So anytime that we run the GFX block, we add 1. And anytime that we Oh yeah, okay, I think I got this. Yeah, so we'll have a GFX tail as well as a block tail, and I'm just counting on both. And then I check. I'll also have an old version of this. Yikes, it's getting complicated, but I think we'll do it. This is concurrent programming and parallel programming. It's always complicated to reason about different threads of execution and everything. Perhaps almost as hard as this kind of reasoning, at least for me anyway. So we are counting any time that we are running the GFX block, and we are counting any time that we are doing this stuff. Then how can it tell if the thing is running? It is running if I was kind of thinking of using the block tail variable as kind of a threshold to check. Yeah, I think that's what I will do. But what I will do is just check if the block tail is bigger than a certain threshold, like 500, and the GFX tail is different from the old one. And then I will also have to do some bookkeeping here. If the GFX block is running, then I will do some bookkeeping. I will zero these variables just for good measure, because I don't want them becoming unboundedly large. But I will also move this into that. And I guess I will have to restructure this code a bit. And there you have it. I think that this does it. I think it works because the way that it's doing its thing is this is always going to run because it's the audio thread. So it's always going to keep counting up, and eventually it will reach a certain threshold. And at that point, we check like we have run the block 500 times at this point. Have we had run the GFX block at least once? Are they different? If so, it's still running. Zero everything. I guess this zeroing of everything could happen unconditionally. And we want to do it in this order. I think that this works, but really, yeah, I think that Tail agrees with me that this probably works. I am not even going to bother with the inner details to make sure that it works, because my earlier solution was much simpler and more elegant. Just check the time. It's probably going to be fast enough. It's already in the block. It will be fine. Just check the time. So reverse. There is another kind of cute solution. It goes like this. You have the tail variable that you increment anytime that the block runs. And over here, you have the tail variable and you decrement by the block size. How is the block size called? I don't remember. There is an S rate variable and there is a block size variable, but I don't remember what it's called. But in any case, just do this, where 60 is the refresh rate. So if the GFX block is running, it is going to try to counteract the increment that this is doing. So if the GFX block is running, this will be less than a certain threshold. Thank you. It's called samples block. And this is just the refresh rate, which will be like 60. So now, of course, this is considering that we are not going to drop frames. But if the GFX block is running, then this is cute, but no. I'm sort of exactly relying on the race condition to try to see if the block is running. No, just look at the time. Look at the time. Looking at the time is okay. Okay, what's up next? We have solved the issue of the jitter. We have solved the issue of... By the way, I am not sure it's always available in the GFX block. That's surprising to me. I thought that the GFX block had access to everything, even things that are unavailable in other places, like the width and the height of the user interface, for instance, and obviously. But I thought that it had access to everything. So good to know. Interesting. And I think that Tail was talking about the sample block variable. But all right, so we solved the issue of the jitter by pacing the reads from the circular buffer. We have solved the issue of detecting whether the thing is closed or the user interface is closed, so that we stop, so that we resync stuff. And we also stopped pushing samples into the circular buffer. So there you have it. We solved all the issues we wanted to solve, I think. So now it's just a matter of going into the waveform component and bringing about all these changes from here, all these insights from here, implementing the waveform to take that in account, so it will behave better when you switch to some other effect and then come back. Right now it's behaving the same as real limit, but we wanted to erase the screen. And it's wasting resources. This 0.1% CPU is pushing into the circular buffer. And when I move to another effect, see, it's still consuming 0.1% CPU. It should drop down to 0. Hopefully. If time precise is fast enough, this should drop down to 0 when we move out, and should be back to 0.1 when we move in. And that's all for next time, because I am not going to do all these things, but that's the plan. Next time, tomorrow, I will be back and I will be porting over these notions that we just implemented, the notion of pacing and the notion of checking for whether GFX block is running. We are going to implement all of this into the real waveform display tomorrow over here on the stream. So thank you everyone who was watching and commenting. Thank you Tail, thank you Bo, thank you everyone else who is watching and not commenting. Thanks to everyone who supports me on PayPal and Patreon and that kind of thing. And I look forward to seeing you back here tomorrow to actually implement all these ideas, these cool ideas from the experiment. And you may think, oh, it doesn't really matter all that much that this bar is moving across and it's kind of jittering. But when we have the scrolling waveform as opposed to this kind of waveform, it really makes a difference. So yeah, looking forward to that. Before I go, I will answer Bo. On another note, did you and Arya try to finish that text script in Reaper? Do you mean the video processor that kind of acts like a typewriter kind of thing, where it draws one character at a time? the thing that made text appear. Yeah, I don't think that we have all the bells and whistles that we promised we would have at some point, but it is functional. I think that Arya is even using it, or he wanted to use it, or maybe he will use it soon. So yeah, that thing exists and it works, and I should have it here somewhere, and I probably have published this on Repack. Well, I don't think it's there, so there you go. Maybe Arya has it. I don't remember where it is. If I have it, I don't remember where it is. But I think we have a version that works. Yeah, I think that we have a version that does the basics of drawing one character at a time. And we should do more video processors. They're quite fun. All right, so thank you everyone, and see you back here tomorrow. Have a good one. And Bo, I hope you get better soon. Bye. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.